So, students, in this lecture, we'll start a new topic of the third chapter, that is a Biot Savart Law. So, in exam, derive Biot Savart Law or state and prove Biot Savart Law. Such type of derivation is asked. Then we have to derive. So we'll start proof of that Biot Savart Law. So before starting, we have to consider this diagram, that is a let point P be the point of interest. This is a point P at which we have to find out magnetic field intensity. Here we have to find out magnetic field intensity. Here the differential length of filament dl. This is a differential length of filament dl, and the current I is passing through it. This current I is passing through this differential length of filament, and so the differential current element is a ideal. So differential current element is product of this I and dl. Dl is a differential length. As shown in this figure, theta is the angle between filament and line connecting the differential length to the point P. So this is a theta is the angle between line connecting to this point P and this filament. Okay, so here we have to consider this diagram, and by using this diagram we have to state the Biot Savart law. So statement of Biot Savart law. Here same figure we have drawn. Here statement, that is a Biot Savart law states that at any point P, the magnitude of magnetic field intensity produced by differential element is proportional to the current of the magnitude of proportional to the product of this current, magnitude of differential length dl, and sine of the angle between filament and line connecting differential length to the point P. Okay, the magnitude of magnetic field intensity is inversely proportional to the square of the distance from differential element to the point P. So magnitude of magnetic field intensity is inversely proportional to the square of the distance. This is the distance between filament and line joining to the point P. Okay, that is the square of the distance from differential element to the point P. So very easy statement. Magnitude of magnetic field intensity, we will start from here. At any point P, magnitude of magnetic field intensity is proportional to the product of current, magnitude of differential length, and sine of the angle lying between filament and line joining to the point P. Again, magnitude of magnetic field intensity is inversely proportional to the square of distance. This is the square of distance between filament and line joining to the point P. Okay, so this mathematical equation, by using that equation we can also state this Biot Savart law. Okay, we have to start from this point P, and magnitude of magnetic field intensity is proportional to the product of current, magnitude of differential length, and sine of the angle between filament and line joining to the point P, and inversely proportional to the square of distance between filament and line joining to the point P. Okay, so we'll, as per statement, we'll mention the equations, that is the magnitude of magnetic field intensity is proportional to the product of current, magnitude of differential length, and sine of the angle between them, that is sine of theta. Therefore we can write equation dH is directly proportional to the ideal sine theta, equation number 1. Then also magnitude of magnetic field intensity is proportional to the square of the distance, that is this is a distance between filament and line joining to the point P, that is dH is inversely proportional to the 1 upon r square. So combine equation 1 and 2. Therefore dH is proportional to the ideal sine theta upon r square. So if we remove this proportionality sign, then dH is equal to k ideal sine theta upon r square, where k is a constant of proportionality And as we know, constant of proportionality k is equal to value 1 upon 4 pi. Okay, so dh is equal to, can write, put the value of k here, ideal sine theta upon 4 pi r square. We'll get this equation. Put the value of k is equal to 1 upon 4 pi only here, and we'll get this equation. The direction of magnetic field intensity is normal to the plane containing the differential element and line drawn from the filament to the point P. Unit vector in this direction is a ER cap. Thus, in vector notation, Biot Savart law can be written as dH bar is equal to ideal sine theta ER cap upon 4 pi r square. So we can rearrange this equation as a dH bar is equal to ideal AR cap sine theta upon 4 pi r square. So we observe here, we know that from vector identity A bar cross B bar is equal to AB sine theta. Therefore, here are two terms, ideal dot of AR cap, that is the ideal cross of AR bar is equal to DL dot of AR cap sine theta. That is a when this is considered as a and this is considered as a B, which is a AB sine theta here applied. So we'll get in that format we can write this equation number 7. That is a dH bar is equal to ideal cross of AR cap upon 4 pi r square. In next slide we can see dH bar is equal to ideal cross of AR cap upon 4 pi r square, where dH bar is a differential magnetic field intensity and ideal is a differential current element, and AR cap is a unit vector from differential current element to the point P. Then total magnetic field intensity at point P is obtained by taking integral. So take the integral of this equation number 8. Therefore, dH integral is a h bar close integral ideal cross of AR cap upon 4 pi r square. We will get equation number 9. So if we consider here, if we consider that current element is located at point 1 and we have to calculate dH at point 2, equation 8 can be written as. So we have derived first in the previous slide this equation, dH bar is equal to ideal cross of AR cap upon 4 pi r square. Okay, so therefore that equation can be written as in this above statement format, that is dH2 bar is equal to I1 DL1 cross of AR12 cap upon 4 pi R12 square. That is if we consider the current element is located at point 1 and we have to calculate dH at point 2. Therefore, here R12, I1, DL1, these terms comes. Okay, so we'll get equation number 10. Then if we integrate this equation 10, we can then we'll get H2 bar is equal to close integral I1 DL1 bar AR12 cap upon 4 pi R12 square. Okay, so here AR12 cap is term is there, which is a unit vector. We know that formula for unit vector AR12 cap is equal to R12 bar upon magnitude of R12 bar. Therefore, we can represent it as R12 bar upon R12. Okay, a magnitude of R12 bar is R12. Okay, if we fill up these values in our equation, then we'll get H2 bar is equal to close integral I1 DL1 bar cross of R12 bar, that is this value we have fill up upon 4 pi R12 cube. R12 into R12 square is a R12 cube. Okay, so we'll get this value. So we have derived in this lecture Biot Savart law statement we have mentioned. So statement is easy, very longer statement, but by keeping in mind equation, that is a dH is proportional to the ideal sine theta upon r square. That is the magnitude of magnetic field intensity is proportional to the product of current, magnitude of differential length, and sine of the angle lying between filament and line joining to the point P. And magnitude of magnetic field intensity is inversely proportional to the square of the distance between filament and line joining to the point P. So this figure diagram we have to keep in mind, and according to that, this is a theta angle, this is a point P, okay, and this is a current flowing. Here we have to consider differential element dl, okay, this is the angle theta. So at any point P, here from here we have to start this statement. At any point P, magnitude of magnetic field intensity TH is proportional to the product of I dl sine theta upon r square. So as per statement, we have to write down equations, add equations, then in a vectorial form write down the this Biot Savart law. Okay, so easily you can mention all this statement. So write down your notebook so that you can recall this statement in a exam. Okay, thank you. We will stop here.